My name is Deepti. I am an international mathematics teacher with over 17 years of experience. In this video, I will cover the entire topic in details. So stay tuned till the end. Thank you. So, the today's topic is factorization. What is this? Like when an expression, see what is factors? First of all, you should know what is factors. What is factors? Factors. Suppose. Wait.
You multiply factors with another number, you get a product. So basically.
Yes. So just like a natural number, right? We learn it natural number in the childhood, right? So the natural numbers, algebraic expressions can also be expressed as a product of factors, right? Just normal factors, you know it with the natural number, but the same thing we'll do it with the algebraic expressions. So algebraic expression can also be expressed as a product of factors, which may be numbers, algebraic variables, or algebraic expressions. Like suppose, for example, 5x x plus 3, right? 5x x plus 3. So how you will break it in the factors? 5 times x plus 3, right? Factors means when you break it, break your number, break your algebraic expressions, like this. So note that the factors 5x x plus 3 cannot further be expressed as a product of factors. Can you express this? Can you break it more? No. This is the last breakdown, right? So 5x and x plus 3 are prime factors of what? 5x x plus 3. Prime factors. Because prime factors cannot be break further, right? So this is the last. So the prime factors, but in algebraic expression, the word prime, in algebraic expression, the word prime, this word, okay, prime is replaced by the word irreducible. What we call it? A prime factor. We have given the name for the natural number, okay, the prime numbers, prime factors and all. But in the higher grade, in the algebraic expression, this prime word we will be replaced by the irreducible. Irreducible means you can't be reduced further, right? The meaning of irreducible means reducible, you can reduce it. Irreducible, you can't be reduced it. So it's a just work like prime numbers. So hence 5x and x plus 3 are irreducible factors of fx x plus c. So basically this name is turned into irreducible factors, okay, irreducible factor. Now we can say that in the algebraic expression 5x x plus 3 are irreducible factors of this 5x x plus 3, right? Understood? Now the process of finding, try to understand the concept, okay? Don't write anything. I will give you the time for writing. This is very important part of the factorization. Once you will understand the concept, then you can do anything in the factorization, okay? Please don't write anything. So the process of finding two or more expressions whose product is given expression is known as factorization. So this is the factorization which we have done it here. The expression that may be multiplied to obtain the given algebraic expression are called the factors. Now I give you one more example. Suppose x plus 3 and x minus 3. X plus 3 and x minus 3 are factors of x square minus 9. These two are the factors of x square minus 9. Okay, that means now factorization is the reverse process of multiplication. See, these two are in multiplication, right? In these two terms we have the sign of multiplication. So the factorization x square minus 9 is a factors of this. So the factorization is the reverse process of multiplication. How? I am giving the more example. Explain with the other way also. In simple word, I explain first what is this. Okay, so here is factors, here is product. Okay, so the factors are 2 times 7 and product is 14, right? Yes, in simple language I explain, then I explain in the algebraic expressions. Okay, so in case of multiplication we write 7 times 2 or 2 times 7, whatever is 14. But in case of factorization, right, 14 is equals to 2 times 7, that is 2 and 7 are the prime factors of 2 and 7 are prime factor of this. So this is the multiplication. What we did it? 2 times 7, when we turn into the 14, what we have done it here? Multiplication, right? As normal thing. You know it. We have done it here, the multiplication, right? But the same thing when you do it in the reverse form, what is this? This is factorization. This is the factorization. This is in the simple word you can understand. When you multiply two numbers, will get it the product. This process is called the multiplication. But this 14, when you break down into two parts, 2 times 7 or 7 times 2, whatever. So this is called the factorization. Understood? In the normal numbers, with the normal numbers, right? Now the other method also I want to explain it with the algebraic expression. Understood, bacha? Yeah? Boys? Any doubt?
Yeah, but
Yeah?
no.
Now come to the, this is with the simple number explanation. Now come to the algebraic expressions form. Suppose here is any algebraic expression. And here is the factors. Now take the same example. We have done it, na? The algebraic expression x square minus 9, and here is x plus 3 x minus 3. So in this case, this is the factorization and this is the multiplication. So we done it in the algebraic expression. We have this thing, right? Remember? Then how you will convert it in this, you know it, right? What is the process? We have done it. x minus 3 plus 3 x minus 3. Then we have used the distributive property and then we got this plot, right? We got this algebraic expression we already done in the last grade. Now this grade, when we do the same thing in the reverse order, okay, factorization is the reverse process of multiplication. So when we do the same thing in the reverse order, you will get the factors. Understood? Any confusion?
No.
So suppose, one more example I am giving here only. Suppose the question is x plus 2 and x plus 3. Okay, bacha? When you solve this, okay, when you solve this, you will be reached to this x square plus 5x plus 6. So when you do this to this, you will call it a multiplication. But the same thing, if you do it in a reverse order, we call it a factorization. Understood? Okay? Perfect. Understood both of you?
Yeah.
Now come to the next part. So generally students really confuse with factor and factorization. So when you understand with the diagram, then it will be a no confusion. Okay, smaller expression is called, so factors are when an expression is the product of two or more smaller expressions, is called a factor of the product. And what is factorization? Factorization is a reverse process of multiplication. So the process of writing a given expression as the product of two or more factors is called factorization. That's it. The example is simple. X plus 3 and x minus 3 are factors of x square minus 9. Since you can write it x plus 3, x minus 3 is x square minus 9. That's it. So in the first category, when we have the question like this, so now you have to remember the GCD or HCF. We have learned in the playing with numbers and you know the LCM HCF topic. In that we found the common number or common multiple from there, right? The same part, the same thing, the same process we will do it here, but with the algebra, okay, not the simple number. So 3x plus 21. Now tell me, which number is common for both?
3.
The greatest common monomial factor by which 3x and 2y can be divided by 3. Yeah, that's correct. So 3 you will take out from the parenthesis. So x remaining is x. So you will write it inside plus 3 times what will give 21? 7. So 3 times 7. So this is your quotient. So the greatest common monomial factor by which 3x plus 21 can be divided is 3. Okay, can be divided as 3, and x plus 7 is your quotient. Or you can write it in the other way also, like you can write it in this way. Suppose 3x plus 21 over 3. Whatever common number is here, you can write it in the denominator. So your answer is, your quotient is x plus 7. This is your quotient. There's no space. Okay, so there is a quotient. So you can write it, yes, 3x plus 21, the factorization of 3x plus 7. That's it, done. So this is the monomial, because we have taken out the single number. Monomial means single number, right? You remember the monomial, binomial. Monomial,
Yeah.
mono means one. When we take out one term, one number, we call it a monomial. Binomial, we'll do it the binomial questions. There are two terms, then we call it a binomial, right? Trinomials, when we have the 3 terms. So this is the first example. Now come to the second. X plus xyz. What is the common variable?
X.
X. Correct. So the greatest common monomial is x. So you can write it directly, like when x is already out. So here is the empty space. Generally students wrong in this part. They have written 0. No. X when already have out. So what is the place with the place is empty. So you will put it 1 there. Okay, not 0. And the x is already out. What are the remaining variable? Y and z. So this is your answer. Okay, this is your quotient. Understood? 1 plus xy. Or you can write it in this way also. X plus xyz over x. So when you write it like this, so this will become x 1 plus yz. X already here, so you can write it only this way. So there are 2 ways for writing. Okay, try this one, third and fourth. Now find out the GCD, common greatest common monomial. Yeah.
2 and y.
4 and 8. What is the common multiple?
2.
Really?
Common multiple? Okay, it's 16.
No. What common 4 and 8? What will be the what is the number which will comes 4 and 8? Both the numbers.
2.
Okay, start with 2. Anyways, let's any other variable we can take out.
X and y.
Correct. X and y. Correct. Now, what is the remaining? 2 is already here. So 2 times 2 will be 4. 1x already out. Only 1x is remaining, right? So we will write it inside. Y is already out. Sign, we will put the same sign, whatever is given in between 2 terms. Now 8. 2 times 4 will give it 8, right? X is already out. 2y, right? 1y is out, only 1y is left. So we will write inside. Now can you tell any other number we can take out? Because 2 and 4 is also a common.
Yeah.
Which number? Yeah, 2 again. So 2 times 2xy. When we have already taken out, so it will become 2 is out, so 2y. So how you will write it? 4xy inside x minus 2y. Now can you further divide it? Can you further factors?
No.
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 So this is your final answer. Or you can do it in other method, like I already told you, or you can do it in the other method, like, you know, the 4x square y minus 8xy square, right? As you know it, what is the common number? What is the common value? 4. Can we take it directly 2, because 2 we have taken here, 2 is here. So total is 4, because 4 is the multiple of 4, 4 is the multiple of 4 is 8 is the multiple of 4, right? So basically we can take 4xy directly. So when you take it 4xy, when you divide it with this and this, so it will become x minus y. So this is your 2y, sorry, it's 2y. So this is your quotient, right? This is your quotient. You can write it this method also.
With z.
Now find the common. So 9 is the greatest common monomial. Now after 9, z. So what is the remaining? 9 times 2 will be 18. Z is already out, only x is remaining. So write down inside. Next, in the next term, 9 is already out. So 9 is out. So 9 times what will give 27? 9 times 3. Y, yes, y is not out. You have to write it inside. Z is already out. So that's it. Done. Right? Now find it this. There is a trinomial expression. You have to find the common, greatest common monomial among all three. Okay? Among all three. So what is the common number? 15, 18, 24. What is the common?
That's my question, right?
Yeah, sixth question.
Yeah. So the common factor is 3.
Absolutely correct. Absolutely correct. Now find the common variable among all three. So x square, here is x. Very careful, first check it. X square, x. So what is the common in all?
Only one x.
Only one x. Absolutely correct. Now come to the y part. Y here is single, here is y square, here is single. So what is the common y?
So it's y once again.
Single common y. Correct. Absolutely correct. Excellent, bacha. So now 3. 3 times what will give 15?
5.
5. X square. Out of x square, 1x is already out. Only 1x is remaining. Write it down. Y is already out. Done. The first term. Now come to the second term. 3 times what will give 18? 6.
6.
X is already out. Y square. 1 y is out. Only 1 y is remaining. So write it inside. Now second term done. Move to the third term. 24. 3 times what will give 24?
8.
8. X is already out. Y is already out. Now done. Close the parenthesis. Answer is here. Okay?
Yeah.
Got it? Very good. Now come to the 7th example. Find the common, greatest common monomial. Between these two terms, what are the common part? There is no, here is single pi, here is single pi. So can I take out single pi? Yeah.
Yes.
Now, here is r square, here is single r. What should I write it next?
R. Just
R, absolutely. Now, open the parenthesis. Pi is already out. 2 square, 1 so, r is already out, 1. So 1 r is remaining. Plus, move to the second term. 2 is remaining. Write it down inside. pi is already out, r is already out, only h is remaining. This is your answer.
Yeah.
Easy?
I got that.
Understood?
Yep. This was
Yeah, happy face. Very good. I hope you are enjoying the video so far. If you find it helpful, please give it a thumbs up. And if you haven't subscribed yet, don't forget to hit the subscribe button. If you have any query or needs practice question, please do let me know in comment. And start. Now the next type is when each term of the given expressions contain a common binomial. Binomial means when your term with two expression, then we call it a binomial. So this is binomial terms, right? Now the second case for the binomial. So you have to find a common binomial factor which can divide 3x 2a minus 5b and 4y 2a minus 5b. So what is the common binomial? Can you find it easily? Yeah, of course.
Yeah, you can.
2a minus 5b is the common binomial, as you can see in the question, right? So this is the common binomial. Once you will be out this, what is the remaining one? 3x
3x and 4y.
plus 4y. Yeah, don't forget the sign. Sign is very important. The other method is, see, this is the answer, but other method is you can do it in this way also. 3x 2a minus 5b plus 4y 2a minus 5b. Okay, so what are the common thing? Same. 2a minus 5b you can see it in this side, 2a minus 5b you can see in the other side. So you can take out the, you can divide it 2a minus 5b. So what will be the quotient? The remaining one, so which is 3x plus 4y. This is your quotient. Okay, this is your quotient. So you can say that yes, the common binomial factor, which can divide it 3x 2a minus 5b plus 4y 2a minus 5b is 2a minus 5b, because 2a minus 5b is the common binomial term which is in this part and this part, because plus sign is separated the expression. Sorry. So you will find it from here one binomial, you will find it from here one binomial, which is common. You can easily see in the question. So easily we can see the common binomial term. So this is your answer. Quotient is simple. See how you will solve this. Here is square, here is single. You have to find the greatest common binomial, because here is binomial common term, you can easily see it. But the difference is not the single one. Here is square, here is single. But yes, of course, we can take the single one. So 3x plus 4y, when we take it out, what are the remaining one? 9.
9.
1 3x plus 4y, right? Minus 15, because it's already one time and we have already taken out. So how you will solve the next part? First part is already simple. We will write it as it is. Now you will use the distributive property and solve this part. Okay, so use this distributive property. How you will solve it? 9 times 3 is
27.
9 times 3 is
27.
Oh, what we can take out, 9 and 15 is also here, na? So you can take, you can common 3 also, right?
Yeah, you can simplify that.
Yeah, so you will take 3, so it will become, here is 3 only and here is 5. Because 3 times 3 will be 9, 3 times 5 will be 15, right? So you can do like this and then multiply it. So 3 times 3 is 9x plus 12y minus 5. This is your final answer.
Yeah.
Okay, so what we
Yeah.
have taken common 3, because negative sign is separating the two part. So now you have to find the common. So 9 and 15, what is the common? 3. And the binomial,
Yeah.
3x plus 4y, 3x plus 4y, 3x plus 4y is common. So what is the remaining
Yeah.
thing? 3 times 3 will be 9. So this is remaining, and because of this is 2 times, so 1 time you will write it here, or 1 time is already out. Minus 15. So 3 times 5 is 15, and this we have already written outside. So here is nothing, only 5. So this is your final answer. Or if you can write it in the division method, so you can write it 9 3x plus 4y whole square minus 15 3x plus 4y over 3x plus 4y. So what are the remaining thing? Yes, when you divide with this, you will get 3x plus 4y minus 5. You will simplify like this. So 9x plus 12y minus 5. So answer remains the same. Whatever method you can use it. Okay.
Okay. Yeah.
There is no change in the quotient. Now in this question, you have to find the greatest common binomial. But see, this negative sign separated this, right? This negative sign separated this, and this is this. Now, but what is the difference here? Here is a minus b is common. Here is a minus b is common. But here is not a minus b. Here is a plus b. But we can change it into a minus b. How? Let's see. So you can write it in the this. You will rewrite the question first. A minus b whole square minus 4a minus b, and if you write it negative sign outside, so it will become a minus b, right? When you use the parenthesis, it will become change. Now you can see, we can easily find the greatest common binomial, right? Easily you can see it in the question. So a minus b, no other number is common here, only a minus b. Okay, write down a minus b is common. Write it down outside. Now, what is the remaining part? So remaining part is 13 and 1a minus b, because here is square, right? So 1a minus b we have written out, so we have remaining a minus b inside. Minus a minus b is already out, only what is the remaining part? 4a minus a minus b is out, you will write 1. Now you will simplify this part. This is little longer. So a minus b, now simplify this. So 13a minus 13b minus 4a minus 1. You can use the simple parenthesis, the normal one. No need to curly bracket. Now, as you can see, there is a 2a term, right? Here is 2a term. So you can simplify, na? So when you simplify, 13 minus 4 will be 9a minus 13b minus 1. This is your final answer.
Okay.
Okay, this is your final answer. Understood the concept? This is the different type of question, means factorization by grouping, or you can say regrouping basically. Okay, so there are algebraic expression in which each term is not divisible by a common monomial or binomial. Not possible always. Okay, in some of these cases, the terms of the given expression can be arranged in suitable groups, okay, such that all the groups have a common factor. Then the process of factorization becomes simple and easier. Otherwise not possible. Okay, so what you can do it in this, you can see in the two separate terms, what is the common in this? What is the common in these first two terms?
There's like a y.
Y. So you can write it x minus z inside. In this second part, what is the common?
X. No, z.
Z. So z, you will write it out. So x minus z. Why minus? Because we have written minus here. When minus, you will write it inside, then it will give positive. Now see, x minus z is common. Yes. Yeah. Now we can have the greatest common binomial. So x minus z we will take out. What are the remaining one? Y minus z. This is your answer. So basically the concept is sometimes it's not given directly the common monomial or binomial. So in that case, what we did, we need to arrange in suitable group like this, right? I have grouped it in the suitable group, right? So that all groups have a common factor. Then the process of factorization becomes easy and simple. Otherwise, not possible to solve this question without arranging this one, okay? So what is the common in the first two terms?
A and AB.
Yeah, so we have taken out A, so 5 plus B is inside. Now the other two terms, what is the common?
B.
B. So when we have B, so 5 plus B. Now you can easily find the greatest common binomial, which is 5 plus B. The remaining you will write it other parenthesis, so which is A plus B. Understood?
Yeah.
The concept. So this is the third case we have done it today. Okay. Now we'll continue the same. Difficulty level will definitely increase. Okay. We'll learn more variations of the factorizations. Okay. In the next class. Thank you so much for watching. I hope you enjoyed it. Please like the videos and subscribe to my channel for more content like this.